Hello, everyone. Welcome, dear participant, to today's online training session on more than two group mean comparison analysis. Yesterday, we have discussed some part of more than two groups mean comparison. Uh, 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 Today is 18th day for this intermediate level training for SPSS. The time is 9 p.m. to 9:40 p.m. Myself, Sahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Halle College of Commerce, University of Punjab, Lahore. These are the contents we have covered in our previous sessions, and we have so far covered single group mean comparison and two group mean comparison as a mean comparison techniques. And we are still on the way towards more than two group mean comparison. We have covered one case for more than two groups mean comparison, and these are some of the topics remaining that we will cover in the upcoming days. This was the topic that we have covered yesterday, and today we will be on the next part relating to the topic. Yesterday we have covered the normal data with equal variance, one-way ANOVA, where I have stated that if your data is normal or if your sample size is greater than 30, it means your data would be considered as normal. You need to use one-way ANOVA method as a method of analyzing more than two groups, and you need to confirm the equality of variance too. Yesterday we have discuss this case. Today, we are going to discuss the normal data with not equal variance. It means we are going to use Welch-ANOVA. So, what was the decision criteria that we need to follow? This is the basic criteria. If you have number of observation less than 30, then you need to test the normality assumption. If the number of assumptions are greater than 30, then you don't need to test the normality. If you are checking the normality and if your asymptotic sig value is greater than 5%, it means your data is normal, then you need to use the parametric test, that is one-way ANOVA, in which you need to verify as a additional requirement the equality of variance. If Levin test is greater than 0.05, it means your one-way ANOVA is validated there. But if your Levin test is less than 0.05, it means unequal variance is confirmed and you are going to use the Welch-ANOVA. So today we are going to cover this part because the data set that we are going to use with this procedure is will be showing unequal variance, although it would be normal, but it will be showing the unequal variance. So we are going to use the Welch-ANOVA for our today's procedure. And if we would be able to have some time, we will also cover the data, the not normal data with Kruskal-Willis test. Otherwise, we will cover tomorrow. So these are the parts that we have covered yesterday. Example one, hypothesis development, its procedure, its interpretation, and its homogeneity of variance. And then I have concluded all the interpretation relevant to this procedure like this. So this was the topic we have covered yesterday. So today we are going to cover the next case, the case number two, normal data with unequal variance. If we have a normal data and we have unequal variance assumed there, then how to deal with that kind of data? So when your data fulfill the normality assumption, but equal variance assumption is violated, the test appropriate for multi-group mean comparison of such data would be Welch-ANOVA. So Welch-ANOVA is used to compare more than two groups on the basis of their average without assuming equality of variance. So always remember that if your data is normal, and equality of variance assumption is fulfilled, then you are going to use one-way ANOVA. But if your data is normal, but equality of variance assumption is violated, then you are going to use the Welch ANOVA. So, what is Welch ANOVA? Welch ANOVA, or analysis of variance, is a modified version of the traditional one-way ANOVA that is designed to be robust when the assumption of equal variance among group is violated. The standard one-way ANOVA assumes homogeneity of variances, meaning that the variances of the group being compared are roughly equal. However, if this assumption is not met, the results of the traditional ANOVA may be unreliable. So Welch ANOVA, introduced by statistician B.L. Welch, is particularly useful when sample variance are unequal. It adjusts the degree of freedom and the test statistic to account for this inequality, providing a more accurate test in such situations. So, assumptions of Welch ANOVA. Welch ANOVA, like traditional ANOVA, has certain assumptions that should be considered for reliable results. So while it is more robust to the violation of assumptions of equal variances compared to traditional ANOVA, it still has some underlying assumptions. Here are the key assumptions of Welch ANOVA. So the first one is the data type. DV must be continuous and IV must be categorical. This is the first requirement. The second requirement is independent. Observation within each group must be independent of each other. The value of one observation should not be influenced by the value of another observation within the same group. And the third one is normality. The dependent variable should be normally distributed within each group. However, Welch ANOVA is somewhat robust to the violation of normality, especially when sample size are large. So always remember, if your sample size is greater than 30, it means your normality assumption is already fulfilled. You don't need to check the normality. But if your sample size is less than 30, then you need to check the normality in order to verify this assumption. Then homogeneity of variance. This is the assumptions which is basically required here. While Welch ANOVA is designed to robust to the violation of equal variances, it still assumes that the variances are not vastly different across groups. Extreme differences in variances may affect the accuracy of tests. So this is the basic feature of Welch ANOVA, that it would support the violation of equality of variance assumption in case of one-way ANOVA. So example number 4, if you have the folder I have provided for the data set, more than two group mean comparison. Here, there is a folder named example number 4 because the first three examples are related to case number 1, which is normal data with equal variance. While the example number 4 is relevant to second case, so we need to extract this example on the desktop and then open this data set so that we can understand the requirement of our example. So meanwhile it is open, let's read our example. So you are provided, let me open this. You are provided with a data of 80 individuals. If you see the number of individuals here, these are greater than 30. It means the data is already normal according to central limit theorem. So we don't need to check the normality of this data. So you are provided with a data of 80 individuals on their test scores by attending training on 3 different methods. So is there a significance difference between each method? So here are 3 different methods. So we need to see whether there is a significance difference between each method of these 80 individuals. So we need to use the data. So let me open the data first. This is the test score, and these are the groups. If you can see here, these are the groups. Group for method 1, 2, and 3. And these are the test score, which is the scale data. So as the sample size is greater than 30, so we don't need to use this data. So what we are going to do, we go to analyze, we go to compare means, we go to one-way ANOVA, and here we need to cover the test score as a dependent variable. We need to put the groups in factor variable, and we need to click OK as a first analysis because we need to see whether the equality of variance assumption is fulfilled or not. Here, the equality of variance assumption is not provided. We go to analyze, go to compare means, one-way ANOVA. We go to options, yes, descriptor, and homogeneity of variance test. We need to check on these options. Click OK. Now, if you see the average mean score or average score for for the students who have used method 1, there are 20 people or 20 students who have adopted method 1 and their average score is 30. And there are 30 people who has adopted method 2 and their average score is 39.73. And there are 30 people who have adopted method 3 and their average score is 62. So if apparently if we see there is a significance difference, but we need to see the sig value of an OVA test. So it indicates that there is a significance difference between these groups on overall. But if you see the Levine test, it is less than 5%. Whenever this test value is less than 5%, it means we are going to use the Welch test for interpreting the mean comparison. So we go to analyze, we go to descriptive, we go to compare means, we go to one-way ANOVA. Here, what you need to do, you go to options and you need to provide the Welch test here. This is the requirement of this test because the homogeneity of variance is not fulfilled here. If you see, the homogeneity of variance is not fulfilled according to this table. Therefore, we need to use the Welch test here. So we go and we need to cover. So Welch test is basically provided as an option here. So you need to check on this and click continue and click OK. So when you click OK, you will be provided additional test in the name of Welch. And if you can see the sig value, it is less than 5%. So here we can say there is a significance difference between three groups in their test score. So we can interpret here. We can create a duplicate slide and I can give the interpretation here. Interpretation. First of all, I need to interpret the normality as the number of observations is 82. 82. If we see the question statement, sorry, 80. Number of observation are 80. As the number of observation are 80, which is greater than 30. Therefore, According to central limit theorem, the distribution of this data is normal. Therefore, we need to use one-way ANOVA for testing the mean comparison. Additionally, we need to verify the uh, equality of variance assumption. If Levine test indicates a sig value greater than 0.05, then one-way ANOVA would be valid for mean comparison. If Levine test indicates a sig value less than 0.05, then Welch ANOVA would be valid valid for mean. Now, this is our initial interpretation regarding the normality and the choice of test. Interpretation for normality and choice of test. As we have find out that Levine tests value or the sig value is less than 5%, so we are going to use the interpretation of Welch test, which is also less than 5%. So what would be our interpretation for Welch test? Interpretation of mean comparison as the Levine test indicates a sig value equal to 0.01. If you see here, this value is 0.001, 0.001, which is less than 0.05. Therefore, validity of variance assumption is violated, and therefore Welch ANOVA will be used for comparing the mean of more than two groups. So this is basically the interpretation of mean comparison. Now, as the value of Welch ANOVA, if we see here the Welch ANOVA value, it is 132.856 and it is significant. It is less than 0.05. So as the value of Welch ANOVA is significant at less than 0.05, therefore we reject the null hypothesis and conclude that there is a significant difference between the average score of three groups. All right. So it is basically the overall result. If you remember, we need to see the overall results. So if you would like to see the results of individual group, whether this group is significantly different from this group and this group is significantly different from this group, we need to go to the post hoc estimation. So we go to analyze, we go to compare mean, we go to one-way ANOVA, and here you will find the post hoc analysis. If you remember that when equality of variance assumption is fulfilled, we check the LSD and Tucky. But in our case, equality of variance assumption is not fulfilled here. So in that case, you need to use either the first one or the second one as a usual application of this post hoc estimation. So let's suppose we check for these two and click continue and click OK. So it will indicate us the group wise comparison. And if you see that method 1 is significantly different from method 2, method 1 is significantly different from method C. So all the methods are significantly different from each one according to Temhan and Donet's T3 consideration of formula, because here the sig value is less than 5%. So this is how you can consider, and in the same way as we have previously interpret the individual group here, like Tucky HSD, there is a significance difference between this group and this group, and we provide the mean difference value and the p-value. So here, in the same way, you need to interpret method 1 uh, in 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 comparison to method 2. This is the mean difference value, and this is the sig value. So this is the way you can interpret this value. So in the same way, you need to check the procedure with example, next one, example number 5. And yes, for example number 5. So I need to discuss example 5, and you will try it on your own self. So a sales manager evaluate 2 new training courses. The 60 employees divided into 3 groups all receive standard training. In addition, group 2 received technical training and group 3 received hands-on tutorial. So there are 3 groups of 60 employees. If you see here, 60 employees. So as the number of employees are greater than 30, so normality assumption is already fulfilled. So you don't need to check the normality here. The 3 groups are: the first group received the standard training, the second group received the technical training, and the third group received the hands-on tutorial. So there are 3 groups comprised of 60 employees. Each employee was tested at the end of the training course and their score recorded. So you will find in example number 5, their test score and 3 groups. So you need to apply the same procedure as I have done now. So is there a significance difference between the score of each group? So you need to confirm this procedure. The last one is relevant to case number 3, but today the time of the meeting is going to over. So we will discuss it tomorrow, the case number 3. So do you have any question regarding today's discussion? Please let me know. Yes, Rabia?
No, sir.
All right, so do practice for these two procedure that I have elaborated today. First, you need to practice the example number 4. Then you need to practice the example number 5 for your consideration for today. So stay blessed. Thank you very much, and let's meet tomorrow with another part of the session, which is the last part for mean comparison. It is multi-group analysis when the data is not normal. So stay blessed and Thank you very much for joining.